Hello everyone, so in this problem we will determine the location of the resultant force, the factor of safety against sliding, the factor of safety against overturning, stresses at the heel and toe, and the unit shearing stress at the base. So before ako mag-start, shout out muna sa mga students ko from FEU Institute of Technology, sina Patricia, Mark, Pauline, Chloe, Faye, Nikolai, si Miles, Anthony, si Ivan Jane, and si Jess Mark. Okay? So, hello sa inyong lahat. Okay, so in this problem, meron tayong dam given yung kanyang. So, isulat muna natin yung mga given. Okay. So, yung unit weight or specific weight ng concrete to be 23.54 kilonewton per cubic meter. And yung specific weight ng water. So, we have 9.81 kilonewton per cubic meter. Okay. And meron daw tayong hydrostatic pressure at maximum hydrostatic pressure at the heel to 0 at the location of the drain. So, dun sa derivation natin, yung hydrostatic uplift pressure natin varies from, okay, so again, that's varies from maximum. So, pag sinabi sa problem na maximum at the heel, and then nagzi-zero tayo dun sa toe kasi nga nakaka-escape na yung pressure dito sa ground. Okay? So, kaya nagzi-zero na dun. So, unting-unting na-disperse yung pressure o nare-reduce yung pressure. Okay, so, tuloy sinabi nga, no? So, it's ideal to minimize yung uplift kasi yung uplift pressure will cause additional overturning moment sa ating dam about its toe. Okay, so one way to do that is yung maglalagay ka ng drain. Okay? Maglalagay tayo ng drain. So, parang dyan, sa drain na yan, sabihin natin, nakakatas or nakaka-escape yung water sa ilalim ng dam natin. Okay? So, kaya nga sabi doon, varies linearly from maximum at the heel and 0 doon sa drain. Okay? So, yung ating uplift pressure is eto lang. Okay? Then, meron tong uplift force. Okay? So, first is the location of the resultant force. So, para makuha natin yon, so we need to determine yung weight ng ating dam. So, we will divide this area into several components, no? So, hatiin natin to. Okay. Okay, so let's call this yung part na to. So let's call that weight 1. So ito yung centroid nito, no? Let's call this weight 2. And sa centroid nitong triangle, so let's call that weight 3. And since meron yung face ng dam natin is inclined, so, meron din tong kakaroon din tayo ng downward force due to the hydrostatic force ng liquid natin. Okay? And this is, so let's say ito yung centroid. Okay, so tawagin natin tong weight 4. Okay, so unahin natin yung mga vertical forces. Okay, so weight 1 is equal to, so we have a triangular shape. So by the way, given kasi yung given yung slope na 1:10. So yung height nung dam natin is 52 meters. Okay, so 1:10, then if this is 52 meters yung height, then yung base ng triangle natin is 5.2 meters. Okay, then this is of course 7, and dito naman sa baba, yung base nitong triangle na to is, so 1:2 yung ratio, no? So 1:2. So kung yung height is 52, so kalahati yung base. So that is 26 meters. So yan, so hanggang doon. Okay. So again, weight 1 is equal to unit weight ng ating again, weight is equal to the specific weight times the volume. So solving for weight 1, ang specific weight ng concrete is 23.54. Okay, so that's kilonewton per cubic meter multiplied by the volume. So yung area muna ng triangle is 1/2. Height natin is 52 meters, and then yung base natin is 5.2 meters. And of course, consider natin yung 1 meter na strip nung dam. Okay, so may ako nisulat dyan. So weight 2, so yung rectangular shape na part nung dam, so specific weight na 23.54 kilonewton per cubic meter multiplied by, so yung area is 7 meters by yung height na 52 meters, and of course yung 1 meter width natin. Okay, then weight 3. Okay, so concrete pa rin, 23.54 kilonewton per cubic meter multiplied by area ng triangle is 1/2. Base times height, base is 26 meters, height natin is 52 meters, and yung width ng 1 meter strip na 1 meter. Okay, then yung weight 4, so this is water na, so ang specific weight is 9.81 kilonewton per cubic meter multiplied by, so this is also a triangular. Okay, so this is 1/2 since triangle yung shape natin. Then yung base is, so yung height alam natin na 50, and since that is 1:10, then yung base natin is 5 meters. Okay, so yung height is 50 meters. Okay, so kung mapapansin natin, makakancel lang naman yung, so meter is meter cube, cubic meter, so cancel lang doon. So ganun din naman dito, 3 meter is meter cube divided by meter cube. Okay, so ang unit lang na may iwan sa atin, okay, so kuha tayo dito ng 1 meter na width. Okay, so let's solve. So we have 23.54 times 1 up is 0.5 times 52 times 5.2. Okay, then next is 23.54 times 7, then times height na 52. Okay, so check ko lang, tama naman na input. Next is 23.54 times, so triangular, so 1/2 is 0.5 times base na 26, then height is 52. Then dun sa water natin, 9.81. 9.81 times 0.5 times 5 times 50. 9.81.5 5 by 50. Okay, so isulat ko lang dito. So we have 3,182.608 kilonewton. Next is 8,568.56 kilonewton then, and 15,913.04, and yung sa water naman is 1,226.25 kilonewton. Okay, so i-total ko lang yung lahat ng downward forces natin, or so of course meron tayong resultant dito, no? Okay, so hindi natin alam pa yung location niya, so i-assume ko na lang na nandito yung ating resultant force R. Then of course meron tayong dalawang components, yung Ry and Rx. So if we sum up, so to determine yung value ng Ry, so we need to sum up forces along the vertical. Okay, so lahat ng mga weights natin are downward forces. Okay, then Ry, then minus nung weight 1, minus nung weight 2, weight 3, and weight 4. So that will be equal to 0. So we can solve for Ry. So which is yung summation nga lang nung lahat ng mga downward forces natin. So i-add ko lang isa-isa to. Okay, so we have yung value ng Ry natin to be 28,890.458 kilonewton. Okay. Kulang pa nga pala tayo. So, okay. So, we have an uplift force na U. Okay, so nakalimutan ko. So, isingit ko na lang dito, no? So, meron tayong uplift force U. So, which is equal to sa volume ng pressure diagram doon sa ilalim. Yung uplift pressure natin. So, this height, ito, no? So, this is sabi nga full hydrostatic. Sabi sa problem. Assuming uplift pressure varies linearly from maximum hydrostatic pressure, okay, to 0 at the drain. So, maximum hydrostatic pressure. So, kung ano yung pressure dito sa elevation na to, which is equal to unit weight ng water, 9.81 kilonewton per meter cube multiplied by height na 50 meters. So 9.81 times 50. Okay, so we have 490.5 kilonewton per meter squared or kilopascal. So yan yung height nitong triangle. Okay, so solving for the uplift force U, so that is, so again, volume na lang, no, nung triangular pressure diagram sa ilalim. So that is 1/2. Ang base natin is 23.2 meters. Yung height is 490.5 kilonewton per meter squared. And then multiplied nung, so yan ang area ng triangle. So yung width natin na 1 meter para maging volume. Okay, so we have 0.5 times 23.2, then times itong 490.5, then times 1. So meron tayong 5,689.8 kilonewton. So, kung wala tayong drain, so halimbawa lang naman, so kung wala tayong drain doon, then it will vary linearly from maximum dito sa may heel, then 0 tayo doon sa toe. So, kung isosolve natin yung uplift force, so example lang naman ito, no? So 1/2 ng base natin, yung base natin ngayon will be, so meron tayong 26 plus 7 plus 5.2. Okay? So 38.2 meters. Okay, so 38.2. So base is 38.2. Yung height ng triangle is yung 490.5, then times 1. So kung titignan natin to, so madadagdagan, magiging 38.2. So nakita natin yung difference ng nung walang drain doon sa may drain. So na-reduce natin significantly yung uplift force. Okay, so ngayon, so kulang pa pala tong value ng Ry natin. Kasi yung uplift force is going up. Then yung summation ng forces, so pataas yung Ry positive. Then yung mga weights natin puro negative. Then plus yung uplift force U. Okay? So kung ibabalik ko to, so, i-add naman, or pag tinranspose kasi yan, magiging negative na yung uplift, diba? So, ima-minus ko ngayon yung uplift force na 5,689.8. Yan. So, yung Ry is, so, mababawasan to. So, magiging 23,200.658 kilonewton. Okay. So, para naman sa horizontal force, okay, so horizontal force FH, so that is equal to, parang ano lang naman ito, no? Hydrostatic force on plane surface. So, we have 9.81 kilonewton per cubic meter. Then, H bar natin, okay, yung depth nung center of gravity or center of area nung vertical projection nung face nung dam. So that is 25. Then yung area, this is meter. Area is 50 meters by 1 meter width. Okay. So 9.81 specific weight times 25 times 50. Isa meron tayong 12,262.5. So this is in kilonewton. Okay. So paano natin ma-locate or ma-determine yung location nung reaction or nung resultant? So again, meron tayong formula that x bar. So yung x bar natin is from the toe. Okay, or galing dito, ito na sa toe. Okay. So, x bar is equal to righting moment minus overturning moment over nung Ry. So, meron na tayong Ry, pero wala pa tayo righting moment and overturning moment. Okay, so move ko lang to. Okay. So let's determine yung mga righting moment muna. Okay. So righting moment is equal to, so unahin ko yung yung weight 1. Okay. So, ngayon alam na kasi natin na ang base nitong ating magandang kulay. Yan. So, dulo-dulo. So, that is 38.2 meters. Okay, meron tayong 26. Meron tayong 27. So, that is 33. Then, meron tayo dito sa gilid na 5.2. Okay, so this is 5.2. Okay. So, solving for writing moment. So, that is yung, hindi ko nasulit yung exact value ng weight 1. So, weight 1, then ang moment arm ng weight 1 from the toe is, so, diba, from toe hanggang dun sa dulo, that is 38.2. Then, itong distance na to, so, ito na lang yung kunin ko. Yan. So, itong distance na to is 2/3 ng 5/2. Ito yung 1/3 ng, itong portion na to, ito yung 1/3 ng 5.2. Okay? So, pwede namang 26 plus 7 plus 1/3 ng 5.2. Or yung total natin na 38.2 minus ng 2/3 ng 2/3 ng 5.2. Okay. So, gamitin ko lang itong 26 plus 7. Again, that's 33. Then, plus 1/3 ng 5.2. So, 33 meters plus 1/3 ng 5.2 or 5.2 meter over 3. Okay? Then, plus so, yung weight to natin, ang moment arm niya is, so, meron tayo ditong 26. So, from toe is 26 plus kalahati ng 7. So, that is 3.5. So, we have 29. Or siguro para mas malinaw, no? So, sulit ko yung 26 plus 3.5. So, naka-meter pares to. Okay? Then, plus, move ko lang konti sa kaliwa. Yung weight 3. So, that is triangular load. So, ang moment arm natin from toe is 2/3 ng 26 meters. Okay? Then, yung weight 4. Anong moment arm ng weight 4? So, gamitin ko yung total length na 38.2. Then, ima-minus ko ngayon yung, so, diba, this is 1/3. Ito. Itong portion na is 1/3 ng 5.2. No, that is 5 lang, sorry. Ng 5 meters. Kasi, diba, ang slope pa rin ito is 1:10 pa rin. 1:10. So, if this is 50, itong height, then yung base natin is 5 meters. Okay? Minus 5 meters over 3. Okay? So, makakuha natin yung total na writing moment. Okay. So, weight 1 is yung 3.1 ito, 3.182 times ang moment arm is 33 plus 5.2 over 3. Okay? Then plus, yung weight to natin is 8.568. Ito yan. Times the moment arm. So, 26 plus 3.5 is 29.5. Okay? Then plus weight 3, 15913, 15,913. Moment arm is 2/3 or 2 times 26 over 3. Okay, then weight 4 natin 1226.25 multiplied by, so meron tayong 38.2 minus ng 5 over 3. Okay, so we have 683,940.1312. So unit is kilonewton meter. Okay. So paano naman yung ating overturning moment? So una natin yung hydrostatic force, yung U. So ito na yung U pala natin. Yung FH muna. Unahin ko muna FH. Ayan. So we have 12,262.5. 12,262.5. This is kilonewton. And then ang moment arm natin. Okay. So alam natin na yung hydrostatic pressure is 0 at the liquid surface. Then varies linearly habang bumababa tayo. So yung location nung horizontal hydrostatic force is at 1/3 nung depth. So from the bottom, this is 1/3 ng 50. Okay. Then yung sa taas, of course, that is 2/3. Okay. So 1/3 ng 50, that is 50 meters over 3. Then plus yung ating uplift. So 5689.8 kilonewton. Then ang ating moment arm is ayan. So pwedeng yung total width nung base nung dam na 38.2. So babawasan natin ng 1/3 ng ito. So itong portion na to is 1/3 ng 23.2. Okay? So yung base ng dam natin na 38.2 meters minus ng 1/3 ng 23.2 or 23.2 meters over 3. Okay. So solving for the overturning moment, yung 12,262.5 multiplied by 50 over 3, then plus yung 5689.8 multiplied by, so we have 38.2 minus ng 23.2 divided by 3. So ang ating overturning moment is 377,724.24 kilonewton meter. Okay? So pwede na natin ma-solve ngayon yung location ng resultant force. Okay? So X bar is equal to, so yung writing moment natin or hindi ko na substitute, i-direct sub na natin dito sa calculator para mas mabilis. So writing moment is yung 683,000, then minus nung overturning moment yung 377,000, then over RY. So nasolve na natin RY, 23,200. Okay, so yung X bar is located at 1986 meters. So this is from the toe. Okay? So, pumasok ba siya doon sa middle third? Okay? So, para malaman natin kung pasok siya doon sa middle third, so, kunin natin yung eccentricity E, so which is equal to, kasi kung, i-drawing ko lang ha, if this is yung base natin, okay, so hatiin natin siya sa tatlo. Okay? This is 38.2 over 3. Ito rin. Then yung gitna, so ang eccentricity kasi is from the center, 'di ba, nung area. So ito yung center ng area. So yung 38.2 over 3 is dinivide pa natin sa 2. So kaya nga ito is magiging 38.2 over 6. So, kapag dinivide pa natin ng 2. Okay? So, if yung eccentricity is less than itong 38.2 over 6, then pasok tayo doon sa ang eccentricity kasi is from, kasi ito yung resultant force, ito yung distance E. Okay, so if that is less than 38.2 over 6, then nandun tayo sa middle thirds. So, solve muna natin yung distance E. So, yung distance E, so tama ba na ito yung x bar? Ito yung x bar natin. And ito naman yung, this is, taas ko lang ng konti. Okay, so this is x bar, this is b over 2. Okay? So solving for E, so based on sa dito sa dimensions na to, then distance E is b over 2, which is 38.2 over 2, then minus no x bar. So yung E, so 38.2 minus nitong value ng x. Oops, mali. 38.2 over 2. Then minus nitong x bar natin na 13.1986. Okay, so we have 5.90141 meter. So, kung i-compare natin ngayon to sa b over 6, (38.2 divided by 6), so 6.367. So, this is less than b over 6. So, pasok yung resultant force natin doon sa middle third. Okay? So next, ano bang next na hinahanap? So nakuha na natin yung para dun sa letter A, resultant force. Location of the resultant force. So next is the factor of safety against sliding. So given yung 0.75 na coefficient of friction. So yung friction force, so sabi nga natin dapat yung friction force is mas malaki, okay, kaysa doon sa horizontal force FH, yung tumutulak ng force. Okay? So, solving for the factor of safety against sliding. So, yung friction force natin is yung mu. Alam natin yan si static, no? Statics. Mu times yung normal force. Normal force natin is yung Ry. Okay? So, mu daw is 0.75. Then, yung Ry is 23,200.68 kilonewton. Then over nung yung force na tumutulak sa kanya para mag-slide siya. So yung FH na 12,262.5 kilonewton. So, of course, wala tayong unit. So, solving for the factor of safety against sliding. Okay, so 0.75 times yung ating RY is 23,200. Okay, then divided by FH na 12,262.5. Okay, so 1.419. So this is yung dam natin is safe against sliding kasi ito yung ating friction force, then ito yung ating horizontal force FH. So mas malaki yung friction kaysa dito sa tumutulak dun sa dam. Okay, so next for letter C, so factor of safety against overturning. Okay. So, ibaba ko lang muna tong sa pang figure natin. So, factor of safety against overturning. So, that is simply yung ratio ng righting moment over nung overturning moment. So, of course, dapat mas malaki itong righting as compared na sa overturning to keep it in its position. So, meron na tayong value ng righting moment and overturning moment, no? So, diretso ko na dito sa calcu. So, righting moment is yung 12,262. 683, okay, 1,000 over nung overturning moment natin na 377,000. Okay, so this will be equal to 1.811. Okay, then we are also safe against overturning. So, mas malaki yung righting moment as compared to sa ating overturning moment. Okay. So, next question is stress at the heel and toe. So, yung stress dun sa soil. Okay. This is 23.2. 38.2 minus ng yung x bar natin kanina. Okay, so 25. So, meaning yung resultant natin is nandito. Wala rito sa side na to ng drain. So, para lang mas malinaw. So, this is yung force F, resultant force F. Then ito yung vertical component FH. Okay. So in terms of reaction, so of course opposite in direction lang naman yun. Okay. Ito yung R. Ito yung RY. Then ito yung ating RX. Okay. So meron tayong dinerive na formula, no, para doon sa pag-solve ng maximum and minimum pressure doon sa soil. Okay? And since mas malapit dito sa right side yung resultant force F natin, so we expect na yung soil pressure natin is mas malaki dito sa side na to. Okay? Then this is yung Q max. Then nandito yung minimum soil pressure. Okay, so solving for the soil pressure Q. So again, that is yung RY over nung width nung base nung dam over B. then multiplied by 1 plus 6e, eccentricity, over nung b. Okay, so again, may derivation na tayo dyan. So, plus or minus. So, hindi naman kailangan i-consider lagi yung negative sign pagka compression. So, importante lang alam natin kung mag-a-add ba yung pressure or magsusubtract. So, kung ito kasing resultant force natin is acting dito sa, let's say, nag-a-act siya dito sa may pinakagitna. Okay? Then, yung pressure natin will be uniform. So, parang ganito. Okay? But since meron nga tayong eccentricity, so, madadagdagan and mababawasan yung ating pressure. So, ito yung, parang ito kasing height na to, yung pressure na to is, yan yung ating Ry over B. So, again, meron talaga yung 1 meter. So, para maging, force over area. So, para maging stress. Okay? Then, pwede siya madagdagan and mabawasan depende dun sa side na kino-consider natin. Okay? So, solving for maximum, so obviously, i-add natin yung, so kailangan naka-positive tayo dito. Then, solving for the minimum pressure, so kailangan natin bawasan yung ating, yung value nitong normal stress natin na Ry over B. Okay? So, solving for Q max, maximum soil pressure, Ry is, ano yung value ng R natin doon? 23,200. Point. Ano yun? 0.658. Kilonewton. Then over, B natin is 38.2 meter by, so yung meron tayong 1 meter strip. Okay. Then multiplied by 1 plus, since kinukuha natin yung maximum, then 6E, ang E natin is yung 5.9. Tama ba? So, 5.9. Nine 0.141 meter. Then over B. So, which is 38.2. So, we can solve for Q max divided by 38.2, then multiplied by 1 plus 6E. Ang E natin is itong 5.9, then divided by 38.2. Okay. So, meron tayong 1,170.311. So, this is in kilopascal. Then, for the minimum soil pressure, so, of course, yun din naman, no? Except, ima-minus lang natin to. So, magiging 1 minus 6E over B. So, 44.383 kilopascal. Okay. So, yung average nitong dalawang na to, so just to check lang kung tama yung pagkaka-input sa calculator. So, yung average nitong dalawang na to, dapat equal siya dito. Okay. So, yung 23,200.658 divided by 38.2 by 1. So, 607. So, kung i-average naman natin to, plus this, then over 2. Ayan, so paras lang dapat. Okay, then yung last question is what is the unit shearing stress at the base? So, unit kasi for every 1 meter strip lang. Okay, so yung shearing stress is yung FH, yung horizontal, yung shear force natin, FH, over nung area. So, force over area. So, yung FH is 12,262.5. So, this is in kilonewton over area natin na 38.2 by meter by 1 meter. So, 12,262.5 divided by 38.2. Kilopascal. Okay. So, yun lang about this example. So, madali lang naman siya kung tutusin yung problem ng dam. So, you have to identify lang yung mga indirection ng mga weights, mga downward forces, okay, mga vertical forces. So, downward forces yung mga weights, and meron tayong uplift force. Then, yung horizontal force natin is yung hydrostatic force or vertical projection nung face nung dam. So, yung FH. Okay? So, pag nakuha mo yung mga forces, so, isolve mo na yung mga righting moment and overturning moments. So, yung mga weights na tumutulak dun sa dam against the ground, so, yun yung magpo-produce ng righting moments. So, yung mga weight 1, weight 2, 3, and then yung weight ng water above nung face nung dam since naka-inclined. So, kung vertical yung face nung dam natin, so wala tayong weight ng water na i-consider. Okay? Then, yung overturning moment, yun yung tumutulak sa dam para mag-tip over, okay? Or mag-overturn. So, yun yung FH, ito, hydrostatic force, and yung uplift force na U. Okay, so yun lang naman yung kailangan. Pag nakuha mo na yan, mga yan lang yung mahabang part eh. So, kung mapapansin nyo, madali na yung mga susunod na solution. So, yung RY is yung summation ng lahat ng vertical forces. So, yung mga weight and kasama yung ating uplift force. Okay? So, kapag nakuha mo na yung RY, may righting moment, overturning moment ka na. So, meron ka ng FH. So, yung mga susunod na kailangan mong isolve is madali na lang. Okay? So, yung formula ng E. So, this is B over 2 minus X bar. Yung formula ng E natin. Okay? Compare mo dun sa value ng B over 6. So, para malaman mo kung paano mo isosolve yung maximum and minimum na na soil pressure. So, if yung value ng E exceeds B over 6, so yung pressure nung, ito drawing natin yung pressure ng soil, bawa lang naman, no? So, kung ito yung base ng dam, so yung soil pressure natin is triangular, pero hindi na yung buong base ng dam yung under compressive stress. Okay? So, ito yung RY. So again, RY is equal to yung volume nitong triangle na to. So which is 1/2 yung base natin. So since this is triangular and ito yung location ito yung X bar natin, di ba? Yan yung X bar. Okay. So, then, this is, itong base ng triangle is, so this is, yung X bar kasi is 1/3. Itong X bar is 1/3 ng base ng triangle, which is, let's say, yung distance A. Okay? Or yung A, again, is yung 3. So, galing dito, yung A is equal to 3 times ng X bar. Okay? So, again, yung reaction, vertical reaction Ry is equal din dito sa pressure diagram, volume ng pressure diagram. So 1/2 base is 3x bar. Okay? Then yung height is yung soil pressure. So in this case, this is yung maximum soil pressure. Then meron tayong 1 meter width. Okay? So meron ka nitong Ry, meron ka ng x bar, so masasolve mo na tong Qmax. Okay? So kahit di mo natandaan yung formula, basta alam mo kung saan nanggaling yun. Okay? So I guess that's it for this example. So I hope wala akong na-overlook sa solution ko or kamali ng type. So madalas kasi ganun or may na-overlook talaga akong value. So hopefully, sana wala naman. Okay. So eto na yung medyo applicable naman to sa maraming types ng problem sa dam. So kung vertical yung phase, so again, so mahahati lang to sa dalawang area. Okay? Then wala ka ng weight ng water. Okay, so gano'n lang naman. So any shape ng dam, so hatiin mo lang siya sa mas simple na shapes, rectangular and triangular. Okay? So kung meron talaga siyang parabolic, so wala kang magagawa. Kunin mo yung volume ng area ng parabolic, then multiplied by width, then you have volume na 1 meter width, diba? Okay? So again, that's it for this example. So I will see you on my next video. So please consider na mag-subscribe. So that will be a big help dito sa channel para maging sustainable yung channel na to. Okay? And please share din para mas marami makapanood. Okay, so again, that's it and stay safe everyone.